So this is the other PhET diagram on the PhET simulation under thermodynamics. And this one goes into that idea of specific heat. So I have rearranged these so they're in order left to right. The brick has the lowest or the smallest value. It'd be like 0.2 something. I don't know. You'd have to look that one up. I don't know brick off the top of my head. Iron is the 0.4. Olive oil is like, I don't know, it's like 2-ish. And then water is 4.2. So I have it like low to high. And so if you have a really, really small heat capacity, like the brick, the specific heat capacity, then what it means is that when you get it colder, every degree that you go down, it only releases a little bit of heat as it's doing it. So I'm going to take the brick, I'm going to take the water, I'm going to link them so they both are going to, so I'm going to make it colder. And what that means is that the brick only releases a little bit, whereas the water is going to be releasing a lot more. Do you see how much more that the water releases? Now they're frozen, so you can't do anything. We take the temperature and check it. Yeah, see, he's super cold. They both are at the same temperature. So now I'm going to heat them up. And what that means when you have a small specific heat, it means that you only need a little bit of heat to raise it by a degree. So the brick that only has like the 2 little E's, he only needs like 2 E's per temperature change. Whereas the water needs a whole lot more E's. Since we don't have any heat going on, you'll notice that some of the energy, so it's all ice right now, so they're letting a little bit of the room temperature warm up the water is what just happened. Okay, so I'm going to heat it up. So look at that temperature. Do you see, I'm going to pause for a second. Do you see how the brick is already, now he's going back down because of room temperature. But you see how much hotter the brick was versus the water? That's because it only takes like 2 E's to raise it by a degree, whereas for the water, it takes a whole lot more. Keep going. See the brick? It's getting hotter and hotter. Every 2 E's, it gets like hotter, hotter, hotter. You see the water? Do you see how it's taking the water forever? So now we've got, the water is now at 100 degrees. So the water now is turning into steam. So these are tricky to look at. Once you've reached the maximum temperature something's going to get before it goes through a phase change, you're kind of stuck a little bit because you aren't going through degree changes. But the whole point was for you to be able to see how those change. So last one of these, why don't you practice this and make sure to understand these ideas.